Welcome to the How to DIY Bricklaying video. We're going to look at building a brick barbecue, laying a patio, erecting a fence, and laying a basic footing. Pick a suitable spot to build your barbecue. Remember to consider the late afternoon and early evening sun before deciding on a site. Begin by dry laying the bricks to establish a basic shape. Ensure the final design accommodates your barbecue coal pan and grill. Now's the time to make any adjustments. Once you've decided on a final shape, remove the bricks. You can now begin to lay the bricks with a sand and cement mortar mix. Refer to the fact file featured at the end of the tape for quantities. When laying your first course of bricks, make sure they're all bedded well into the mortar. This can be done by sharply tapping the bricks with the edge of your bricklaying trowel. It's important to lay your first course of bricks with care, as these are the main foundation of your barbecue. If you're unhappy with any of the bricks you've laid, don't be afraid to take them up and relay them. After completing your first course of bricks, you must make sure all your horizontal and verticals are true. Use a good quality level to achieve this. Now remove any excess mortar. Make sure that the legs extend from the back wall to exactly the same distance. Any fine adjustments can be made at this stage. By using your level, you can align the face of the bricks by hand or by using the edge of your trowel. Measure the width of the rear wall and transfer this measurement to the front. Adjust the front if the two measurements aren't the same. This, coupled with your previous adjustments, will make for a perfectly square base. Once you've completed the barbecue base, you may now wish to consider customizing the basic design. Here, we've decided to extend the left-hand side to provide a useful shelf. At some point during the construction, you'll need to cut a brick. It's very important that you follow this procedure. 1. Mark your brick, allowing for the mortar joint. 2. Always wear eye protection. 3. Make sure the brick is on a sound surface. Use a wide-bladed chisel and strike this with a lump hammer. 4. Neaten up the cut edges with the chisel and hammer. Always lay the cut edge of the brick inwards, leaving its natural face outwards. Remove any excess mortar. Continue to lay further courses. Remember, under no circumstances should the joint in one course of bricks be matched up to another joint on the next course. Joints must always be staggered for optimum strength. Spread the mortar over a few bricks and tidy up to minimize any spillage when tamping down your next brick. Then, form a V down the center of the mortar. This allows for easier adjustment and leveling of the brick to be laid on top. After you've laid a few courses, check your vertical and horizontal alignments with the level. Make any adjustments required. This should be done to all laid faces, sides, back, and so on. We've now reached a point where the support for our barbecue pan is required. In this instance, we've used a full brick rotated at 90 degrees to the side walls. When laying one brick on top of or next to each other, make sure that the joint is full. That's to say, there's no air pockets in the mortar. This will stop any water building up in bad weather, which would eventually lead to cracking should there be a frost. Remember to level up as you go along. At various stages throughout the construction, check your vertical and horizontals, making minor adjustments where necessary. Here we've left this joint dry, in other words, no mortar between these two bricks. This will allow a reasonable airflow to help out when lighting the barbecue coals. Now lay the last few courses to finish off the barbecue. Always remember, with a garden project like this, there's no hard and fast rules to their design. Build a bit of individuality into your projects. When the mortar is firm to the touch, it's time to start pointing. You'll notice that a pointing trowel is smaller than a bricklaying trowel. This is to enable you to reach the corners and generally makes the job a lot easier. As you can see, pointing is a fairly simple process. It enhances the final effect and also improves resistance to water penetration. Never attempt to point up your bricklaying whilst the mortar is still wet. This will only make the job more difficult and can spoil the professionalism of your job. Any gaps can be filled with small amounts of mortar. Now clean out any of the mortar that may have blocked the air hole. Brush down your brickwork with a soft bristled brush to clean off any loose bits of mortar after pointing. We've decided to include an integral wine rack with our barbecue using land drains. First, lay a bed of mortar to build a support wall. Leave enough space for the wine rack between here and the barbecue wall. Lay your bricks as before. Realizing that a quantity of half bricks will be required, we've pre-cut these in advance. After laying a couple of courses, spread mortar to start laying the wine rack. Make sure you achieve a tight fit. Use the same procedure to lay as many drains as you like. It's advisable to cap these off with a garden slab or something similar. This can now be leveled up. Next to our barbecue, we're going to build a brick planter by removing a slab from the patio. Dry lay the bricks as before to determine your size. You may wish to remove 2 or 3 slabs. Lay your bricks on a mortar bed. Use exactly the same bricklaying process as with the barbecue. For example, no joints lining up, and so on. Even though this is a small structure, it's still important to level up the horizontal and verticals with your level. It's very important to lay slabs on a sound base. This will minimize any chance of movement. Here we've used broken concrete roof tiles as hardcore. Spread your dry slab laying mix over the hardcore. Refer to the fact file at the end of the tape for quantities. The mix needs to be at least 60 millimeters deep. Level this out with a bricklaying trowel and rake a few channels with the point of the trowel. This will make leveling up easier. Now it's time to lay your first slab. Always keep your back straight and bend at the knees when lifting heavy objects. Lay the slab gently so as not to disturb the bed. Tamp down the slab. In this instance, we've used the shaft of a lump hammer. Note the fall of the slab from left to right. If you're laying a patio, the fall should always be away from the house. Here we've achieved an average fall, being about 15 millimeters over 600 millimeters. Lay the spirit level onto the slab and tamp down the side you wish the fall to run until the bubble sits about halfway on the line, instead of falling in between the lines. This must be consistent with all the slabs to achieve the same fall. Check that the slab is stable on its bed. If there's any movement on its diagonals, tamp more of the mix under the relevant corner or corners, then recheck. Now that you've a starting point, continue to lay the slabs from your first slab. As you lay your other slabs, ensure the edges butt up to each other to maintain squareness. However, it must be pointed out that this is only the case when the slabs being used have a straight edge. Some slabs have a riven, uneven face and need a gap of some 10 to 15 millimeters between each other when laid. If you decide to use these, after laying them, brush the same dry mix into the joints. This will harden from the moisture in the sand. Once your first row of slabs are down, start the second row. If you transfer over your levels with the spirit level, there'll be no need to work out the fall on each slab again. They'll all transfer over. Due to the size and weight of concrete fencing posts and concrete gravel boards, you may find it easier to enlist the help of a friend with this project. Begin by laying your concrete posts flat. Space them out by cutting a piece of timber to the same width as the fence panels being used. Lay all of your posts on the ground, spacing them with the same piece of timber. Now begin to dig your holes for the posts. These should be a minimum of 450 millimeters. Remember, when purchasing your concrete posts, they should be a minimum of 600 millimeters longer than the measurement of the fence panel and gravel board added together. For example, in this demonstration, the fence panel is 1500 millimeters. The gravel board is 300 millimeters. Therefore, the concrete post being used is 2400 millimeters. Now lower your first concrete post into the hole. Whilst it's being held upright, shuffle the concrete mix, refer to the fact file at the end of the tape, around the base of the post. Tamp this down with a firm object. Here we've used timber. Now check the verticals with your spirit level. Run a length of string from the finishing point to the first concrete post. Adjust this to a height of approximately 300 millimeters from the ground. Then double check that there's enough height on the post to accommodate the fence panel. The string will act as a horizontal guide for the top of each gravel board. Now position your first gravel board. Make sure it's inserted into the slot on the post. Now position the fence panel on top of the gravel board, making sure this is into the vertical slot on the post. Now, temporarily lower the string to the ground to enable easier maneuverability of the second post. Insert this into the second hole, driving the slot well onto the gravel board and fence panel. Check your verticals, and the post can now be concreted in as with the first post. Repeat this process for as many boards and panels as you have to erect. Always make sure that the fence panels and gravel boards are tight between each post. start by cutting several lengths of timber stakes. Fix them together with a hammer and nails. The two uprights must be spaced as wide as your footing needs to be. Measure the distance from where your footing needs to start. Find the center point and mark this with a nail. At the other end of your footing, mark out exactly the same. Now, run a length of string from one nail to the other. This strung line is now exactly parallel to the fence at the rear. With a spade, mark out about 150 millimeters either side of the string. Now dig this out to a depth of about 300 millimeters. Fill the trench with a concrete mix. Refer to the end of the tape for quantities. Level out with a spade. Then check with a spirit level. Getting the footing as level as possible will help you when you come to lay your first course of bricks. Leave the concrete for 24 hours before attempting to lay your bricks. Welcome to the How to DIY Central Heating video. Our first project is going to be draining down a central heating boiler. With most central heating projects, it will be necessary to drain down the central heating system. Locate the drain-off valve on the boiler, usually situated at the lowest point. Attach a length of hose and loosen the valve to drain down. Open the air vent on the highest radiator in your central heating system. The air intake will speed up the drain-down process. Fitting an extra radiator. Measure up the size of the room where the radiator is to be fitted. A good plumber's merchant or DIY store will recommend a suitable radiator size. Locate the pipework near to where the radiator is to be fitted. Lift a floorboard and cut across it in the middle of the joist. Remove the floorboard. Now feel the pipes. The warmest of the two pipes will be the flow. In the majority of cases, the flow should always be piped to the left-hand side of the radiator, the right-hand pipe being known as the return. Label the flow. Now's the time to drain down your central heating system and isolate the electricity supply. Transfer the centre of the fixing brackets onto the top of the radiator. These can then be easily marked onto the wall. Mark the horizontal or top of the radiator across this vertical mark. Now square this to the other mark with a spirit level. These marks now become the top of the fixing brackets. Mark the positions to be drilled and plugged. Now fix these to the wall. In this example, we're fitting a thermostatic radiator valve. These are generally fitted to the flow, that is, the left-hand side of the radiator. Apply a quantity of PTFE tape around the external thread, making sure it's wound in the opposite direction to the thread. Tighten the valve into the radiator. There are several types of valve fixing. This particular valve needs a spanner. Ensure the valve is tightened up as much as possible. On the other end of the radiator, a standard valve will be fitted. This valve needs an Allen key to be tightened. Again, make sure a good quantity of PTFE tape is used. Now hang the radiator onto the brackets and check that it's level. Insert a small length of pipe into the valve in order to mark where the floorboard needs to be drilled. Remove the radiator from the wall and drill the hole. The joists will need to be cut in order for the pipes to run up to the radiator. Do not cut away any more of the joist than is absolutely necessary, but remember to trim an extra few millimeters to allow for lagging at the end. Mark the pipe holding the T-fitting next to it. A section will have to be removed to accommodate the fitting. Here we're using a pipe slice, which gives a good clean straight cut. A hacksaw can be used, but the rough edges will need to be cleaned up. Hold the pipe firmly and cut out the section required. This is the removed section that will be replaced by the fitting. Apply flux to the pipe and fitting. The flux stops the metal oxidizing when heat is applied for soldering. Fix the fitting and pipes together. Cut a length of pipe to suit. You'll encounter situations where standard angles are not suitable, so you will need to bend the pipe. In this example, we're going to use a pipe bending spring. Insert the spring into the pipe. Gradually bend the desired radius over your knee. Remove the spring and test. Mark the pipe and cut as necessary. Apply flux to the pipe and fitting, and now connect together. For ease, remove the valve to be piped up. Bend a 90-degree angle into the pipe. This is required to raise the pipework above the floorboards. Always try to run your pipework along the straightest route. Avoid too many elbows, as this can restrict the efficiency of the system. When you're bending pipework, try often, as it can take some time to get it exactly right. Trim the pipe to length as required. Varying angles can be bent into one length of pipe if you need to. Mark and trim the pipes to size. Finally, flux all the remainder of the joints and assemble ready to solder. Remove the nut and olive from the radiator fitting and put these onto the copper pipe. This type of fitting requires a sealing paste before assembly and tightening. Spread the paste over the pipe and olive. The part of the fitting which attaches to the radiator also requires an amount of paste. Reassemble the valve and hand tighten. Now it's time to solder all the fittings. Take care that no electric cables or fittings are nearby. Generally, when solder drips from the bottom of the fitting, this is a good indication that the joint is full of solder, but it will be worth visually checking that this is the case. Leave the pipework to cool and wipe it down with a damp cloth. Now, tighten the compression fitting with adjustable grips. The flow supply feed is now complete, and you follow the same procedure to pipe up the return. It will be worthwhile to insulate the pipes where they pass through joists. This will help stop creaking and knocking noises. Here we're using air felt lagging, which can be obtained from merchants or DIY stores. Now replace the floorboards. It's advisable to drill and screw the boards for easy access. Fill the central heating system back up, remembering to bleed the air from your radiators, starting with downstairs first. And lastly, check for any leaks. Fitting a thermostatic radiator valve. A thermostatic radiator valve can be fitted to most of your radiators. This will give you individual temperature control for each room, which can result in lower fuel bills. First then, drain the central heating system and open the valve on the radiator. To remove the valve, 2 spanners will be needed, one to steady the valve, one to undo the tail. This avoids any unnecessary strain on the valve or pipework. Always use a dust sheet, as there's usually a bit of water left in the pipework. Bear in mind that some thermostatic radiator valves are not compatible to the radiator valve tails. If this is the case, it will have to be removed. Remove all the components. Check to see if it fits on the flow or return. Assemble the valve and tail. Decide which way fitting is preferred, following the manufacturer's guidelines. You will need to wrap PTFE tape around the thread of the fitting. A good quantity will be required, as this will help to make a watertight seal. Now fit and tighten as before. Apply some sealing paste to both threads on the valve. Reassemble, and finally tighten up with spanners. Use the second pair to steady any movement or prevent any strain to the valve or pipework. Secure the head of the valve and refer to manufacturer's guidelines on temperature control. Replacing a radiator. There are various reasons for replacing a radiator. For example, damage, rusting, changing from a single to a double, and so on. Radiators can be changed without draining down the system. Always remember, thermostatic radiator valves will need to have the sealing off cap fitted to enable complete isolation. Turn off both the flow and return valves. Before removing the old radiator, measure it up so as to purchase the correct replacement size, eliminating the need to alter your pipework. Now, with 2 pairs of grips, loosen the valve and tail. Place a bowl underneath and open the air vents. This will force the water out of the radiator. After the water has drained, place some tissue in the valves. This will stop any drips going onto the carpet. Turn the radiator upside down to stop any water spillage. Some tails are available which have already been coated with a sealant. These will not require an application of PTFE tape. If you do not have these pre-coated tails, use the PTFE tape as we mentioned earlier. Fix these tails into the radiator as before. Place the new radiator onto the brackets. Apply some sealing paste to the valves and then tighten up. Now, remove the thermostatic radiator valve sealing off cap and refit the thermostatic radiator valve. Reopen the valves and bleed off the air. This process should never be done with the central heating pump on. All you'll do is pump air into the system. Fault finding. One of the most common causes of your central heating system not working is when the pump has not been used for some time, for example, throughout the summer months. Remove the center screw. Manually turn the pump with a screwdriver. Replace the cover and test. If this process fails to work, the pump will probably need replacing. When bleeding air from your central heating system after any alterations, always start to bleed air from the lowest radiator, finishing with the highest, and never have the pump running while carrying out this procedure. If you find that you're having to bleed air from your radiators on a frequent basis, you may be experiencing one of 2 possible problems. Firstly, your heating system could be producing hydrogen, which will be produced from a corroding radiator. This can be controlled by corrosion-proofing your system. This is a liquid treatment that is added to your central heating header tank. Follow the manufacturer's instructions. Secondly, over-pumping can occur by having your heating pump set too high. Reduce the speed setting until the problem is controlled. Welcome to the How to DIY Year-Round Maintenance video. In this video, we're going to look at a number of tasks that should be completed around the home throughout the year. To begin with, we're going to take a look at loft and pipe lagging. When lagging a loft, it's important to wear protective clothing, that's to say gloves, masks, goggles, and overalls. The reason for this is that the lagging is made up of glass wool, and it can be very irritating when it comes into contact with the skin. Carefully roll the lagging in between the loft timbers, taking care not to tread on the supported plaster ceilings. Cut off lengths as required using a sharp knife. Continue to work across the loft space. A space should be left around the outside of the loft to allow for air circulation. It's advisable to discard the protective clothing when you've finished, as it will be contaminated with the glass fibers. All exposed pipework should also be lagged, especially in garages, as they're prone to freezing during the winter months. Lagging is now readily available to suit different pipe diameters. It's a very simple process, as it usually comes pre-split along the length. Simply cut to size with a junior hacksaw and position over the exposed pipework. Make sure the lagging is fitted properly around the pipes, leaving service and drain-off valves visible. When fitting the lagging around junctions, cut out pieces to get a good fit, as shown here. To put a longer length on, run the hacksaw blade down the split, open up the end, and slide onto the pipework. Fitting a service valve. We recommend fitting service valves to all water-fed appliances. This will enable you to isolate any of the appliances should you need to carry out any work, eliminating the need to drain down your cold water system. Here we're fitting a service valve to an outside tap. Begin by turning off the incoming water supply at the stop tap. Turn on the tap to drain down any water in the pipes. If there's a drain-off valve nearby, open this as well. Mark the position of the valve on the pipe. Remove the tap from the wall. Now cut this section of pipe out with a pipe slice or hacksaw. As with all compression fittings, a sealant paste is required. Take the valve apart. Place the nut and ring over the pipe. Apply a quantity of sealant paste over the end of the pipe, as shown. Assemble to fitting and hand tighten. Repeat this process with the other side of the fitting and pipe. Reassemble, making sure the isolation screw is facing outwards for easy access. Refit the tap back to the wall. Tighten the fitting with 2 sets of grips or spanners. Turn the water supply back on and check the valve functions correctly. Cleaning a sink trap. This is something that should be done on a regular basis, as a build-up of debris is inevitable. Remove the sink trap by unscrewing the knurled plastic nut. Empty the contents into a bowl. Always replace the rubber washer before refitting. Replace and tighten the nut by hand. Stop tap repairs. A common fault with most stop taps is a leaking gland. Begin by removing the gland behind the stop tap. Twist a length of PTFE tape together to form a strand. Wrap this around the exposed shaft behind the thread. Replace the gland and tighten with a pair of grips. Remove the excess tape and turn the supply back on. Re-grouting and sealing. Over a period of time, the grout in between ceramic tiles becomes stained and dirty, especially where a lot of water comes into contact with it, for example, kitchens, bathrooms and showers. Remove the old grout with a re-grouting tool. Remove 2 or 3 millimeters. Brush off all the dust from the tiles and the surfaces. Always wear rubber gloves before starting to grout. Spread the grout with your applicator, making sure all the gaps are filled. Fill in any screw holes that are no longer required. After completing, wipe over with a damp sponge. And finally, wipe over with a lint-free cloth. It's always advisable to seal the tiles where they meet work surfaces, etc. Apply a length of masking tape along the surface 3 or 4 millimeters away from the wall, masking off any returns. Put the tape onto the vertical face of the tile, again 3 or 4 millimeters away from the work surfaces. Once the entire area has been masked off, run a bead of silicone between the 2 pieces of tape. Run a dampened plastic spatula along the silicon bead to form a V. Leave the silicon to form a skin, then remove the masking tape. A neat, perfect seal has now been achieved. Repointing. Severe weather conditions causes old mortar to crumble, which becomes porous. If this happens, it will require repointing. Remove any loose mortar with the point of your pointing trowel. Dampen down the wall with water to avoid quick drying out. Use small amounts of mortar on your pointing trowel and position carefully between the bricks. Take care not to get mortar on the brick faces. Apply mortar in small amounts in between the vertical joints to begin with. After the vertical joints have been repointed, start on the horizontal joints. You might want to practice the pointing up procedure in a small, inconspicuous area before attempting a large, prominent area. Remove any excess with the edge of the trowel. Repairing leadwork. It's important to check that the leadwork is secure. Here you can see that this step flashing is away from the wall. Reposition the lead back into place and make sure it's tucked well into the joint. A lead wedge can be made to secure the step flashing back into the joint. Cut a strip about 20 mm wide. Tightly roll it up together. Cut off slightly oversized compared with the brickwork joint. Remove any excess. Now flatten down one side to form a wedge shape. Firmly place in between the bricks and lead flashing. Hammer it in firmly. The edge of a chisel can be used. Firm down the lead. We would suggest repointing the gap in between the bricks at this stage. Replacing roof tiles. If a roof tile appears to be cracked or broken, it's essential to replace it immediately, as water can penetrate through into the roof. You'll find that tiles are only nailed to the laths about every fourth row. Therefore, it makes replacing tiles very easy. Lift the tiles above the tile to be replaced. Twist around and remove the broken tile. Replace this and reposition the other tiles. Making sure all are secure. Here you can see how the tile hooks over the lath, with these lugs towards the back of the tile. Cleaning an air brick. Air bricks are an essential part of any building, allowing air to pass underneath the suspended floor. These should never be blocked up, as without any airflow, timber rot can set in. Remove any build-up of debris or cobwebs with a garden cane, making sure there are no blockages. Checking windows. Underneath most window frames is a routed drip throat. Unlike this example, make sure that they're never blocked or obstructed. Rainwater can cause serious damage. If the throats are blocked, the rainwater will run back towards the brickwork and cause damp patches to appear on internal walls. If cable, usually aerials, go through a door or window frame, ensure there's a drop loop before it enters the timber, so as not to let water run along it and into the brickwork. Hinge maintenance. A common fault with decorated doors is that the hinges get clogged up after years of redecorating. Rub glass or sandpaper along the moving parts of the hinge. Then use a good quality oil to lubricate the hinge. Work the door back and forth to spread the oil evenly. Cleaning a gully. Gullies can get blocked up with garden rubbish. Remove the cover, always remembering to wear rubber gloves. Take out any rubbish. This should be done on a frequent basis. Cleaning gutters. Gutters tend to get blocked up during and after autumn. Remove any leaves or rubbish that have built up over a period of time. There are various products available that help prevent small leaves or pine needles getting into the gutters. If you do not take out any preventative care, the downpipes can become blocked. Handy hints. T-pieces can be fitted to all overflow pipes, for example, toilets and tanks. This will prevent any cold winds blowing up the pipes and freezing the water. On the top of soil and vent pipes, a bird cage can be fitted. Check and remove any growths appearing in gutters and chimneys. We would recommend fitting toughened glass in all low-level doors or windows. After frequent use, limescale can block your showerhead, reducing the water flow. By removing the showerhead and scrubbing with a small brush, ideally an old toothbrush, this is best done under a running tap. Make sure all holes are free from lime buildup. Replace the showerhead and check. Cleaning your washing machine filter should be carried out frequently. Locate your filter. In this case, it's situated at the front of the machine. Remove the panel and unscrew the filter. Take out any clothing fluff or debris. Replace the filter, making sure it's screwed up tightly. Occasionally, central heating pumps can stick, especially after summer. Remove the center screw and manually rotate with a screwdriver. Replace the cover and test. Oh, always remember to isolate the power supply before you attempt this procedure. Changing tap washers. Dripping taps can generally be cured by replacing washers rather than changing the taps. Isolate the hot and cold water supply. Remove the tap head. The washer housing can now be removed with a spanner. Simply loosen and remove. Don't be concerned if a small amount of water is retained in the tap housing. This is quite normal. There are many different sizes of washer available. Make sure you obtain the correct one. Remove the old washer and replace with the new one. Now reassemble the tap. Turn on the hot and cold supplies and check. Glazing. Here we're going to glaze a new door. However, the process is exactly the same for reglazing. You'll find that putty is very oily. To remove the excess oil, empty the putty onto a piece of newspaper. Smooth it out with a putty knife. The newspaper will absorb some of the oil. Peel the putty from the newspaper. Break a small piece away and roll it into a ball. This can now be spread across the rebate in the door, using your thumb to spread it evenly. Now before you handle the glass, wear protective gloves. Insert the glass into the aperture, pressing firmly around the edges. Secure the glass with a few pins around the edge. Now put more putty onto the outside of the glass. Once this is completed, use the edge of your putty knife to smooth over. Removing the excess. Slight tidying up may be required. Gently smooth over with your fingertips. Leave it to dry completely before you attempt to decorate. Radiator valve repairs. Frequently turning radiator valves on and off can result in the gland weeping. Remove the cap and retighten the gland with a pair of adjustable grips. Wipe off any water and replace the cap. Open and close the valve, making sure it's not too stiff.